Now what we're going to do is we're going to work on adding and subtracting radicals. Now if I'm looking at these radicals, the only way we can add or subtract radicals is if the root and the radicand, what is underneath the radical, is exactly the same. So we're going to treat it like a variable. So if I'm going to come off to the side, if I did 7x minus 2x, we know that we can combine those because they have this variable in common. And then we're just trying to figure out what's the amount that we have in common. So we do 7x minus 2, or 7 minus 2, we end up getting 5x. All right, now I can do the same thing with radicals. So if I had like 3 square root of 2, and I added 6 square root of 2, since they are the exact same radical and root, we can combine them and say we have 9 of those. Now, if I did 3 square root of 2 plus 6 cube root of 2, we can't do that because my roots aren't the same. They have to be the exact same root, so square root or cube root. And what's underneath has to be exactly the same. So now what we're going to do is we're going to look at how we can actually add these or subtract them. Now, if you look right now, the radical is the same. It's a square root and a square root, but the radicand is not the same. It's 272. So we're going to go ahead and break it up. We're going to have to simplify. We might be able to combine these, but we have to determine that first. So I'm going to break it up into a bunch of primes. So if I break up 200, then break up 100, break up 50, and break up 25. Now remember, it's a square root, so I need sets of 2. Here's a set of 2, and here's a set of 2. I brought out 2 and 5. So this becomes 2 times 5. And then we still have that square root of 2. I'm going to do the exact same thing for 72. I know that's 8 and 9. That's 4 and 2. That's 2 and 2. The 9 can get broken up as 3 and 3. So 72, 8, 9, and 4 are not prime. We're going to be looking at all our primes. Square root again, I'm looking for sets of 2. So I have a 2 and a 3. And I still have that 2 that I didn't circle. That didn't have a set with it. So that's got to stay underneath the radical. Now this is 10 square root 2 minus 6 square root 2. Now you can see that we have the exact same radical and radicand, so I can combine them. I have 4 of those square roots of 2. And it would work the exact same way if we had variables. All right, so you still want to make sure that that radical, the root, is the same, and what is underneath the radical, underneath that root, is exactly the same. So the only way I could do this, say it was 3 square root of 5xy, and I was adding 6 square root of 5xy, I can add these because this is the same as that. It's a 5xy and a square root. We have 9 of these. This, though, we really can't combine. Even though these are exactly the same, which is what we're interested in, I can't combine 3x and 6. So I would just leave it like that. All right? So we're always trying to determine whether or not we have that same radicand, same radicand, 5xy, and the same root, square root, cube root, or whatever it is. So that's how you end up adding or subtracting your radicals.